All right, here's 6.5 properties of logarithms. So if you have the same base in two different logarithms, you can add the two logarithms together and combine them into one logarithm like so. We'd get a new log, still would have the base of b here, and what we're going to do to the contents of the two logs, the arguments, is multiply them together. So this is going to be log of b, and then the contents would be x times y, okay? And if we're subtracting two logs with the same base, then you're going to be dividing the contents. It kind of makes sense because logs are, you could rewrite them as expressions with exponents. And if you remember when you multiply to if we multiply, say, x to the second times x to the third, you would add the exponents together, right? That would give me x to the fifth. And if you are dividing with the same base, then you subtract the exponents. So the multiplication and the addition kind of go hand in hand, both with logs and with exponents like that. Same thing, subtraction and division go together like so. Okay, so I'm usually going to write the this when we're dividing. I'll write that with a fraction. Okay, so logs with different bases. Or coefficients cannot be combined. Okay, so if we've got different bases, there's nothing we can do about that. If there's a coefficient, there is something you can do about it, but you have to use what's called the power rule first. So here's how the power rule works. If you've got a log where the contents of the log has an exponent, you can take this exponent and rewrite it as a coefficient. So I could move that x out here, and now I've got x times log base b of a. Okay, and we can do that in reverse too. So now it's a coefficient. I could move that coefficient to become an exponent. Okay, so let's try that out on these examples on the right here. I can take this and move it like so. So then 5 times log base 4 of x, that's equivalent, right? So I just rewrote that using the power rule. I can do the same kind of thing here. Even though I could figure out what 3 to the 4th is, I'd want to use the power rule here. So this would be 4 times log base 2 of 3. Okay. So with that in mind, looking at this next example, if I want to combine these, well, I do have the same base. That's good news. They're both base 2, but I've got these coefficients that I have to deal with. So what I'm going to do before I combine this, I'm going to move the coefficients into the exponent slots on both of those. So now I've got log base 2 of 5 to the third plus log base 2 of 6 to the second. Okay, and so when I combine these, I'm going to be multiplying these parts together. Okay, and you could do the exponents right now, or you could do it later. It doesn't really matter. So here I'll simplify a little bit. 5 to the third is 125, and 6 squared is 36. Okay, so when I combine this into one log, I'm going to be multiplying 125 times 36. Okay, and it's early in the morning, so I'm going to use a calculator for that. 125 times 36. 4,500. Okay, and it's true I could evaluate log base 2 of 4,500, but I'm not asked to do that. I'm just asked to write this as a single logarithm. So that's what I've done. Okay. All right. So same kind of thing here. I've got a base of 2, so that's good news. But first I got to move that coefficient into the exponent slot. Okay, now I'm going to multiply, since I'm adding these together, I'm going to multiply the contents together when I combine. Okay, I could write x to the 4th times 5, but I usually write that as 5x to the 4th. Okay, Now, some people might look at this and say, oh, I could move the 4 in front as a coefficient, but you actually couldn't do that because only the x is raised to the 4th. The 5 is not raised to the 4th, so you got to be careful with that, okay? If it was the quantity 5x raised to the 4th, then I could use the power rule there, all right? Okay, so over here, same kind of thing. Oh, this time I'm subtracting, so I'm going to be dividing the contents, but I still got to move that 3 to begin with using the power rule. Okay, and then when I combine these, I'm going to divide the contents. The first one goes on top always, so it's going to be x to the 3rd over 7. I'm going to take x to the 3rd divided by 7. And I think it makes sense to, when you have a fraction, to put your fraction in parentheses, just so it's really clear, so it doesn't look like my base is 57 or something like that. It can get a little confusing, so it helps when the contents get a little more complicated to put them in parentheses. Okay, I wouldn't want to use the power rule here either because the 7 isn't raised to the 3rd. It's not the whole fraction is raised to the 3rd, only the numerator is. Okay. All right. We've been combining logs, but we can also take a log and break it apart. So that's if the contents have either something multiplied together or divided, then we can use these rules in reverse. So looking at this, this first example here, I've got 5 times x, right? So remember when we were adding 2 logs like this, we multiplied those contents together. We multiplied the 125 and the 36. So we can do the reverse here. We can break this into log base 2 of 5 plus log base 2 of x. Okay, because now if you combined it, you'd end up with that, right? We're just doing this backwards, okay? And since I've got division here, I'm going to be writing this as subtraction. So log base 3 of x minus log base 3 of 5. Just using that rule in reverse. If I combine them, the contents would be x over 5. Okay, that's what I want. Okay. All right, this we can actually do. We can do 2 steps. So I could first do use the division to write it as subtraction. I could do log base 7 of 8x minus log base 7 of 3. And I actually still have some multiplication, so I could go further with this because, hey, I've got 8 times x as the contents there. So I could write this part of log base 7 of 8 plus log base 7 of x, and then I still have minus log base 7 of 3. So if I'm expanding it all the way, that's where I'd get. Okay. All right, on the next page, we're going to look at the change of base formula, something which I've already covered if you're going through these videos in order. I think it's kind of weird the book waits until now. So you can change the base of a log like so. I could write this as log of A over log of B. That way these are both base 10. These are both common logs. So there's a lawnmower going by outside. Hopefully you can't hear that. But okay, these are both base 10, and that's usually what you'll want to do is write them as log base 10. And I remember that the A goes on top because in the original A is higher up than the B. So the A is high up and the B is low, just like that. And I could change this into any base that I want as long as I use the same base on the top and the bottom. It's just the common log is going to be the most handy one because it's programmed into our calculator. Another one that's programmed into the calculator is the natural log. So I could write natural log of, that's a cursive ln, of A over B. So that might be useful too. I don't know why you'd want to turn it into base 7, but you could do that. And you could do any base you want. Okay? All right, so use a calculator to evaluate. Well, this is my common log. This is the type that's already programmed in the calculator, so all you have to do is hit the log button, which is about halfway down on the left, and then 10. So this is really, my base is 10, so 10 raised to some power is going to equal 10. This should be 1. Hey, and it is, right? So maybe you don't need a calculator for that, but it's 1, okay? Now the rest of these aren't base 10, so this one I'm going to have to think of this. Some calculators you can, they'll give you a little cursor down there and you can put whatever base you want in there. Mine doesn't do that as far as I know. So I have to use the change of base formula. So I'm going to think of this like so. Now I've got it in base 10 on top and bottom, so I can hit log of 12. Make sure you close those parentheses, and then divide by log of 3. If you don't close the parentheses right there, then the contents of the first log would be 12 over log of 3. That's not what we want. We want log of 12, which is some number, divided by log of 3. It doesn't really matter if you close the parentheses at the end, but it does matter with the first log. So that's about 2.26. Okay, and you could try it out. This means 3 raised to the 2.26 would equal 12. That's approximately 2.26, so this is not going to come out exact, but this should be really close to 12, and you can see it is, right? If I used more of the decimal up there, it'd be even closer to 12. Okay. All right, so let's try this one. I'm going to write this as log of 100 over log of 7. Then I'm ready for my calculator. Log of 100, close the parentheses, over log of 7. Okay, and I got about 2.37. Okay. All right, next up, zoom out a little here. This is going to be log of 9999 over log of 5. By the way, you could also do this as natural log of 9999 over natural log of 5. So let's test this out to see if those both come out the same. Okay, close those parentheses, divide by log of 5. Got that decimal. Let's just test it out. The natural log button is right below the log button on these graphing calculators, that ln button. So ln 9999, close parentheses, divided by natural log of 5. And it get the same thing. So that works. Okay, so this is about 5.72. Okay, and I kind of just talked about the natural log button, but yeah, it's right below log, and so natural log of 55 comes out to very close to 4. So I'll call that about 4.01. So remember that this is base E. It doesn't ask you that here, but that's good to know. That means E raised to the 4.01 would be about 55. Okay, so you could try that out. And I didn't type in the old decimal, so it's not exact, but pretty close there, right? You can kind of test it out. All right, and then natural log of 777. There we go. It's about 6.66, sorry. Okay, that's the end of the section, and I'll see you next time.